Now, many of you know that each and every year we use Solidworks World as an opportunity to introduce you to some of our coolest and most unique customers.
Passion for great design has our next guest on an incredible journey. Their obsession for extreme vehicles has caught the attention not only of the United States government, but rescue and police organizations around the world. Now Discovery Channel has taken an interest, and they have a show. It's Black Ops Brothers, Howe and Howe Technology. Let's take a look. Pretty intense. Please welcome Jeff and Mike Howe.
Darren, thanks for having us, brother. Thank you. Our history starts, a lot of people ask us, you know, big question. How'd you do it? Where did it start? Those are some of the real big questions that we often answer. And it's funny, my mother sent us a picture about a year ago. Hadn't seen it in years, and it kind of brought back the memories of where Mike and I started our endeavors. And it started really back when we were young, because I think we always had it, and I'm sure there's a lot in this group that have always had it, and kind of started at a young age. We were 8 years old when really our first program got started. We call them programs. And our first one was a simple log cabin. And it sounds small. Is there a picture of it? There it is. Look at that thing. I got that picture a year ago. It looks like nothing, but there's really a fascinating story of that's where we started. Mike and I, our father wasn't around when we were younger. My mother was a teacher, bringing up 3 children, and really we didn't have money. We didn't have any way to really build and do our designs that we wanted. We were continually taking apart can openers. I remember getting shocked. First time I got whacked with 120, I don't know, I was 6 or 7 years old, and it was by a can opener. And I was so upset about that. And I said, at that point, never again. I did get shocked later on in life, as we probably all have. But stay away from 120. That's the lesson on that one. But the log cabin really kind of symbolizes where we needed to go and what we needed to do. Mike and I, if you've seen the show, you know what we're all about. It needs to be bigger. It needs to be badder. It needs to be the best. It needs to be, you know, better than anything else. And it started at a young age. I mean, all our other friends had, you know, their cabins, or not even log cabins. They had their little forts, and we saw their forts, and Mike and I said, okay, well, we have no money, but we have the will, which will give us the way, and we will do a log cabin to kind of upstage everybody. And we did. We set out to do it. This log cabin was not built with chainsaws. It wasn't built with, you know, anything electrical. It was built with one hand axe. I remember we'd come back from school with blisters and get off the bus and head down and build it, and chop down the trees and get it done. Except one time, coming home from school, knock on the door, and it was really a depressed time. It was a problem, because I'll never forget it. My mother getting yelled at by the neighbor because we cut down all his trees. Oh. True story. And we did. I mean, we took the best trees. I mean, they were straight. They were just beautiful. We didn't take any of the, you know, and getting into this is failure. Right off the get-go. Boom. We have it built. It's 4 feet tall. It's not finished. It's just a half shack at this point.
Yeah. And so we realized, you know what, we're going to fail on this one. I guess we'll put a roof on it, and it's failure. But we learned at a young age, failure really isn't not an option for us. So we toiled with it. What are we going to do? We have no lumber. We have no 2x4s. We have no nails. We can't cut down any more trees. What are we going to do? A week later, we decide, you know what, you can't build up, you build down. So we saved up a little bit of our money from our allowance. I think we got 75 cents a week back in the day.
Which would buy an 80-pound bag of concrete.
That's right, 80-pound bag of mortar. We dug down diligently, laid the foundation, and gave it a little floor. And that is really our first program. And you can even see there, we did hand split. Just a funny point of that picture. First of all, that big log on the top, that was a big one. I remember that one, chopping away at that. You can see it's unfinished. We just decided not to keep cutting it. It's even got a zip line, that pole attached to it is a zip line that goes over the pond. So we had fun while we were doing it. Long story short, the log cabin kind of story was where we started and where we started to learn, you know what, we're just not going to stop. We're going to keep going, and we're never going to fail.
Great story, and I like the way how you designed around the challenge.
Yeah.
So let's fast forward to the extreme vehicles you guys are producing. You're producing quite a bit. Now, this was actually a passion project as well, much like the log cabin. It was just you two guys getting together, and I know that when you decide to do something, you seal that with a handshake.
Yeah.
And that's how this worked. Nobody was contracting you to do this.
Right, and that's the sign of our company and what we do. We really are out there to innovate. And not necessarily innovate through requirements, but innovate because that's what we do. We're inventors and we like to innovate. So, for example, I'll go to Jeff and be like, I have a really good idea here.
I'll be like,
I want to make, yeah, and he's usually like that. I want to make the world's fastest tracked vehicle ever assembled. 16 inches of suspension, make it more like a Baja race ride than a tank. And so I'll go to him and say, I think we should do it. Now his typical response is,
absolutely not. We don't have any money, we can't do this, we can't do that. So I'm kind of the pragmatic, I'll think through it.
So I'm selling my brother before we even try to sell it to the public or anything. And I usually win, so it'll be like, he'll come to my side and say, okay, and we'll do this. Now the second we shake, and we've paused actually just like this several times and walked away and said, okay. Because what this means for us is true sense of commitment. And the second that we shake, it's getting done unless we die. Now, that may mean that we have to remortgage our house, which is done, Jeff had to do twice for the ripsaw because back then we really didn't have the funding. But we get to it and we say, okay,
this is it.
This is it. Boom. Once that's done, it's now a rolling program. And we have to basically put every material that we have behind it. If we have the finances, that's finances. Refinancing a house, yes, you have to do that. And so we continually, push the envelope and try to find no limitation. I mean, it's very easy to find excuses, but we find that, there's no limitation. We can actually build this thing. And the unique thing with this vehicle is it was a massive engineering challenge because track vehicles aren't designed to go 80 miles an hour. You have huge tracks that weigh 3,000 to 4,000, 5,000 pounds. How do you spin those so fast that they don't fly off the machine? How do you make a track vehicle to have 16 inches of suspension and M1A has about 6 to 8? How do you do that and not make it so when the suspension compresses and the track does not, it doesn't fly off? Well, we looked at a different track suspension and we didn't find anything out there. So we knew we had to do it from scratch. But just because we couldn't find anything in a track vehicle does not mean that there's nothing else out there that we couldn't look at to emulate and kind of get a head start. What goes on a track at high speeds that if it comes off, it can kill you? And the answer was a chainsaw. So we took a look at that design and said, if we kind of make our tracks a little bit like a chainsaw and guide it like a chainsaw, I think we can solve this problem. That with an active take-up on the suspension system and a couple other things we developed allowed us to create a vehicle that today the Army has bought and is now using just from thinking outside the box and taking, not taking no for an answer because we were financially strapped at first with this program.
And the ripsaw basically too was a ground up vehicle. It was a ground up design. And that was really important because we took a look at it and we said, wow, we need to change this, we need to change that, we have to really start from scratch, ground up, take a look at the tracks, take a look at the suspension, take a look. So it really grew from the ground up instead of a program that's morphed onto another program, morphed on another program.
Let me expound on that a little bit more as far as system theory and how that works. One thing we do is we do not get overwhelmed by the big picture.
Yeah.
We take each thing, we call it strat, system theory research, and we attack each problem individually and attempt to solve the bigger problem. Now this project here had a lot of different problems, from how do you drive that track, how do you keep the track on, how do you steer, how do you have, you have differential steering, how do you do that and hold 14,000 foot-pounds of torque? How do you do it in this package, how do you do it small? Where do we get the power from? How do we get that much power? So there's all kinds of different issues that you come across, and what we decided to do was let's solve each individual problem first. So we solved the track problem, we solved the suspension problem, we solved the motor problem, we solved the final drive, which by the way, the final drive, for everybody out here that likes to crunch numbers, we clutch 14,000 foot-pounds of force in a 14 by 3 inch disc.
Open environment.
Open environment. Never been done before, to our knowledge. And so these are some of the challenges that we had to basically find out solutions for one by one. And that's the key, Darren, one by one, finding out and not getting overwhelmed by that bigger picture. So that's the Ripsaw story in a nutshell. And actually, an interesting story to that is actually how the Army actually found and discovered Ripsaw.
Yeah, I'll kind of take that. How we got money, and it's probably pretty important to a lot of the younger inventors out there now that want to do it, and that's another question that we get a lot is, how did you guys do it? How can I do it? How can we do it in this environment? And basically, we decided to take our invention. We heard of a great thing. It was called the DARPA Grand Challenge 2005, and I'm sure a lot of you guys know what the DARPA Grand Challenge was, but basically, it's an autonomous robotic event. We decided to take the Ripsaw, which was manual drive at the time, and challenge ourselves even further. And that challenge is really twofold. One, make it remote control, and then two, make that remote control autonomous, and then enter into the DARPA Grand Challenge 2005. How do you do this without any money? Well, we worked our jobs. Every Friday we'd come by, put the money into the pot. This is how much we have, this is how much we have. We put our feet to the ground. We went out and solicited. Out of all the solicitations that we did for probably a year to try to get into this race, we got one that gave us money, and that was Underwood Engineers, and they were an engineering group that we work with. Wonderful, can't talk to them. But basically, they gave us $10,000 to enter. I had to refinance my house, not once, but twice. And we did it. We did the DARPA Grand Challenge 2005. Out of 179 teams, we qualified 41st. It wasn't great, but we were going up against universities with major endowments. We were going up with companies with major money. It was Mike and I, a team of volunteers that we collected from the universities like UNH, UMO, collectively got together and said, hey, we can do this. We did it. We actually did not compete in the race because we couldn't find the money to get out to California, but we qualified here or over in Maine. So that's the story. Boom, another failure story. Well, we kind of did it, but we almost didn't do it. That leads into, what are we going to do now? DARPA Grand Challenge was done. Luckily, because we did that, they called us back 6 months later, and they were doing an automotive show, DC Auto Show in DC. And because it was a unique track vehicle like that, it's never been seen before, it was autonomous, and this was before autonomy was, autonomy 2005, kind of the next branch in what we're doing. They invited us. We have to get down there.
Yeah, so we had zero money. I know this is kind of a common theme, but we didn't. It's kind of the story of our younger life. And so we asked them, we said, look, we'll make it down there if you guys can pay us to come down. We just don't have any money. They kind of chuckled, they laughed, they said, look guys, there's 167 teams we can choose from. We chose you guys as one of three. You guys just find a way to come down here, or we're gonna pick somebody else. So at that point I turned to Jeff and I said, I think we had $350 to go down there. Yeah. Now that's with truck and trailer, and we had budgeted everything out, and we found out that $350 would basically get us down there. But we didn't know how we were gonna get back, but at that point, we'll figure it out when we get there, let's just get there. So we hit the road, we went down there, and our exhibit was right next to, lo and behold, the United States Army robotic exhibit. So we're pretty happy with that. An interesting thing happened. Through about 3 days of exhibit, the Army kept realizing something through this exhibit, that every time the lights went down and we shut our robot off, their robots would actually start working and would actually start functioning well. So they came over to us, one of the lieutenants came over to us and said, hey, do you guys notice something every time that they shut the power down here, that your robot starts working right? And we're like, no, I mean, ours has been working since we got here, it works great. Well, what we found out was we developed such a powerful system, such an encrypted system, that our system from Maine, from the Howe of Maine, was actually shutting down the US Army's robots.
Remember, go big or go home. Now, I'm not saying these radios might have been legal, but
so the moral of the story is, opportunity. When opportunity presents itself, you never know when it's going to happen. The Army ended up coming up to us and said, hey, we need this, guys. We're going to help you guys get funded. This is a great technology. And that finally got the ball rolling, so I don't have to talk about us not having funding anymore. But it really is about opportunity. And And that's how the Ripsaw story unfolded.
Yeah, it's a great story. It seemed like you had some marketing designed into the...
Yeah, we sure did.
What's interesting though is they are still a small manufacturer in Maine, and they now win, now that they have the attention of the government, they're winning great contracts, and now you're competing against the big boys.
Yeah.
You know, I know there's major contractors in your market, but you still constantly win. What's your advantage?
You know, that's a great question, Darren, and we're proud to say that we compete against the 4 big boys, being just 2 brothers from Maine, with speed and efficiency. And that's the key. That's the niche that the smaller companies can really thrive on. And we do that with SolidWorks. We do that with the interface of SolidWorks and how it's so intuitive. We can actually design so quickly. You know, and Jeff can kind of give an example of, hold on, Jeff. This arm here that we're looking at is only 3 weeks old. We just developed it. Jeff, go ahead.
Speed is really critical, and like Mike touched upon it, without speed we're nothing. Because that is our big advantage over the multi-billion-dollar industries that we're competing against. This is a robotic arm right here, 3 weeks old, 4 weeks old. I was going on vacation, and this robotic arm really is, we had a problem that we needed to solve, and that is basically we need a robotic arm that's not electric. This is basically built for some of our philanthropic stuff that we're sending back to the firefighters. And they need something that can get wet, possibly even go underwater. And Mike and his engineering team sat down and said, look, we're all pointing to hydraulic. Has it been done before? And this size, this much weight, can it have this much force? We couldn't find it. So Mike and his team sat down and said, you know what, we're going to design. I said, Mike, hold on. You know, we have to think about this, kind of go through it. Is this really a program? We have all these other programs that we have to do. Should we really allocate our resources? Mike said, you know what, I'm going to get done. It's just going to get done really quickly. I said, okay. I left for Florida. I get down there. A day later, on my iPhone, I literally got a picture of that and another picture of that already rendered, done. A week later, or that day it went to our fabrication center, and a week later we had that arm fully functioning. So 9 days with the design. I don't know how many guys you had on that team designing it. Two people designing it. In 2 days, I don't know how many hours you guys stayed up, 25 hours?
There were some late nights there, but let's just take a look at the big picture of this specific robotic arm. Everybody builds these now, right? Well, not like this. This one is a hydraulic rotary coupled. It's of 6 axes, 5 are rotary free axes, all hydraulic motors, and we can pull 2,000 pounds. We can pick up 2,000 pounds with this arm. It only weighs 300 pounds. So not only was it quick, it was innovative. And we did that with SolidWorks, and we did that with some motivation. So, you know, another nice feature when it comes down to it, as innovators, how good are you at innovating and getting your product out there if you think it in your head, but you can't get it out to other people?
Right.
And that's where SolidWorks and the rendering capabilities of this comes into effect, where you need to be able to convey it so people can understand it. And I've been asked many times on some of the renderings, are those real pictures? No, they're just renderings. And so it's a really good tool to be able to allow us to actually sell what we think.
Yeah. We're glad to be a part of that.
Thank you.
So we've visited Howe and Howe in Maine, and we sat down with Jeff, and one of the things that really struck us as interesting is how much you give back. And it's not only spending time with different charities, but you actually use your design talents, you know, to give back and help people.
Sure.
Can you elaborate on that?
Yeah. If anybody's seen the program on Discovery Channel, the most influential and profound project that we did was the RIP chair right there. Yes, we have other programs all over here, and we do many, but that one right there was real. About as real as it can get. It touched us in our hearts. It touched us. It touched everybody in the program that was working. It's called the RIP chair. For a guy named Rocky, who is a vet who basically spent his time providing us freedom, and in the meantime lost his freedom. And he wanted to just get out and do what we take for granted every day. He wanted to go out and explore, fish, hunt. Can't do it anymore. Even if it's a river on the side of a road, he can't do it. So he said, look, we're going to do this for you. Our cost, we're going to get it done. So we built the RIP chair. And the rip chair he owns now, and he's driving it and giving us feedback. And that actually spawned into another program, and this kind of fits into the philosophy that Mike and I have. If we don't give back, how good are we? If we don't give back to society, if we don't give back, what are we going to die? You know, maybe multi-millionaires or billionaires? I don't want that. I want to give back. And so our push is to push the younger people, push everybody just to give back, and how much better we will be, and really do it by example. We're starting a nonprofit, and it's already started, and we're designing the world's first disabled park with trout ponds, with on a river waterfall campsite with wildlife refuge, so that they can get out and experience what we experience. And that's some stuff that we're doing. It's really true and dear to our heart, is really giving back. And certainly Solidworks, I mean, that was a program that we had, I think, 2 weeks to build, 3 weeks to build.
Yep.
And designing it, and the engineering team probably took a couple of days, 2 or 3 weeks, and it's on the floor a week later.
It's great. It's great. Great story.
Thank you.
So I said it in the beginning, it's an incredible journey, and the doors keep opening up. The show's doing great. I know you have 8 vehicles on your website,
Yep.
right? They get smaller, and you have large ones, and there's
those are just the ones we can show you.
That's the ones you can show us. So what's next?
Well, we work with the private sector. We work with obviously the public sector and the military entities. And what's next is to expand. We're now.
Although Super Bowl Sunday,
Yeah.
I caught a trailer for a movie,
Yeah.
G.I. Joe.
Yes.
I seem to recognize some of these vehicles.
You might have.
You guys going Hollywood?
I can't talk about it too much, but all I can say is June 2012. Be looking for a movie called G.I. Joe 2. You guys may actually recognize some stuff in there. So we're expanding all over, doing the military stuff and Hollywood.
Yeah.
Very good. We look forward to it. We congratulate you. We think it's great stories. We love the vehicles, and we're glad to be a part of it. Thank you.
Thanks, Darren. Thank you, guys.
Thank you.
Thank you, Solidworks.
Wonderful crowd. Thank you.